All right, so today's a huge day. We get to change from standard form of a quadratic equation to vertex form, or what I call graphing form of a quadratic equation. This is familiar to you because you've already had two different forms of a linear equation. So you don't have to write this down, I'll just show you really quick. But you remember that a linear equation has standard form and slope-intercept form. So let's say I gave an equation like 2x plus 3y equals 6. You don't have to write this down. We know that that's in standard form, right? And if we wanted to change it to slope-intercept form, we would just solve for y, solve for y, solve for y, right? And then we would get y equals negative 2/3 x plus 2. And you're smart enough that you recognize this equation in slope-intercept form is equivalent to this equation in standard form. It's just a different form, right? And it makes it easier for us to graph it when it's in slope-intercept form, but it looks nicer when it's in standard form. So the same thing is true of quadratic equations. They look nicer when they're in standard form, but when we move them over to vertex, or also known as graphing form, you're going to recognize that it's a lot easier to graph the equation. So for example, here's an equation, quadratic, y equals x minus 2 squared minus 1. You recognize that this shifts right 2, down 1, so it's pretty easy to see that the vertex is 2, negative 1. Axis of symmetry, vertical line through the vertex, right? The vertical line through the vertex would be x equals 2. Don't forget the x equals. And by direction of opening, we just mean, is it up or down? Is it smiling or frowning? And this one's smiling, right? So it's up. Now, I'm not here to do the graphing calculator, but if you have a graphing calculator and you put this equation in the graphing calculator, you'll find that this equation has the same vertex and has the same axis of symmetry and has the direction of opening the same as the other one. So you might be like, hey, I wonder if these two equations are somehow related. So let's take this first equation like we did on the homework last night and FOIL it out, right? So we're gonna get FOILed again, or not get FOILed again there. So that's gonna be x squared minus 4x plus 4 minus 1. And when we combine our like terms, x squared minus 4x plus 3, ta-da. Right? So this equation that was in vertex form, when I FOILed it out, combined my like terms, now it's in standard form. So we could see like, yes, those are the same equations. And it's not hard to go from vertex form to standard form. You did it on the homework last night. What we're going to really learn today is to do the reverse. Oh, first it says, if you were asked to find the vertex and axis of symmetry, which form would you prefer? You would prefer vertex / graphing form, right? That's the one that tells you the shifting patterns. So that's the one that we like better, just like we like slope-intercept form better when we're graphing a line. So what we're learning today is then, if something is given to you in standard form, how can we switch it to vertex form? And it's just going to be a series of steps, right? So here's the original equation, x squared minus 4x plus 3. I'm going to write the steps on the side here. So first step is going to be separate the first two terms. Separate the first two terms. So we just kind of separated them, and if you notice, we've got a blank here, and that's intentional. And I'm going to add a blank on the other side. This is going to remind you of something that we did last week, right? Complete the square. Add to both sides, right? We always have to add to both sides. So what are we going to add here to complete the square? Well, you remember the pattern, right? Half the middle number squared. So half of negative 4 is negative 2. Negative 2 squared is 4. But we have to be fair, so we add to both sides. But you might recall that in quadratic equations, the y kind of likes to be alone, right? The y doesn't like people on its side. It's like, can you just move over to the other side, please? So what we're going to do is after we add to both sides, we're going to get the y alone. In this case, by subtracting 4. So now it's kind of done for us. And then all we have to do is factor our perfect square trinomial. And it's intentionally a perfect square trinomial. We made it that way by adding the 4. So now x minus 2 squared minus 1. We've changed our equation from standard form to vertex form. And I call it vertex form or graphing form. So try it on our own here. So what do we have? X squared minus 10x plus 21. So we're going to separate the first two terms. X squared minus 10x, leave the blank, plus 21, leave the blank on the other side. Half the middle number squared. Half of negative 10 is 5. 5 squared, 25. Always adding it to both sides. The y doesn't like things on its sides, so we got to scooch it over. Subtract 25 from both sides. And then when we factor, x minus 5 squared minus 4. Now it's in graphing form. Now you notice I didn't have you graph it here on the notes. On the homework we will. Try another one. Y equals x squared plus 6x plus 4. So we separate the first two terms. X squared plus 6x, leave the blank on both sides. Half the middle term squared is 9. Scooch the 9 over.